All right, today we're going to apply properties of rational exponents. You might want to make yourself a little comfortable, get you some good notes because this could take a minute, but they're really good. You need to know this really good. First of all, the properties of exponents we've done before. These 6 properties are exactly the same ones we had before. The first one, if you multiply, you add. If you have a power to a power, you multiply. If you have an exponent outside, it applies to everything inside. A negative exponent flips the number. If you have division, you subtract the exponents. If you have a fraction, you do the top and the bottom to that power. Wow, we did all this before. Today, we're going to find out that those same properties work with fraction exponents. So no matter what kind of exponent it is, those properties work. So we're going to go through these examples. That's pretty much all I have left on this whole entire video are a bunch of examples. Stop as much as you need to. Need to make sure you understand the examples the best you can. Of course, we'll do a lot in class tomorrow too. All right, first one, 7 to the 1/4 times 7 to the 1/2. The rule there is when you multiply the same base, you add exponents. So I'm going to add 1/4 plus 1/2. 1/2 is really 2/4. So I'm really adding 1/4 and 2/4, which is 3/4. And that's it, 7 to the 3/4 power. All you can do on that one. The second one, I have an exponent outside, which is a 2. Remember, it goes for everything inside. So I really have 6 to the 1/2 squared times 4 to the 1/3, that's a 1/3, squared. And if I raise a power to a power, I multiply my exponents. The 1/2 and the 2 just cancel, that's 6. If I do 4 to 1/3 times 2, that's 2/3, so I get 6 times 4 to the 2/3. And guys, that's all you can do, and that's okay. Sometimes your answer is going to look like that today, and you just got to be okay with it. Part C, going to do a little trick here on part C. Because I can't multiply those numbers because they both have, they're different bases, so I can't add the exponents. So what I'm going to do is, because they're both 5th powers, I'm going to do this. I'm going to say that's the same thing as saying 4 times 3 to the 5th power, because the 5 goes for both of them, and all that's raised to the negative 1/5 power. So what that gives me inside, it gives me 12 to the 5th, and I still have this negative 1/5. Now remember what you do with exponents. With exponents, when you raise a power to power, you multiply them. If I multiply 5 times negative 1/5, I get 12 to the negative 1, which is just 1/12. All right, a couple more like those. This one's division. Remember, when you divide, you subtract exponents. That's really 5 to the 1st power, so it's 1 minus 1/3. 1 minus 1/3 is 2/3, so I get 5 to the 2/3, and that's good enough. Part E, I'm going to do this one just like I did part C a second ago, so I'm going to move this over so you can kind of see it. Anytime my exponents are the same, what I'm going to do is, even though my bases are different, I'm going to rewrite that. I'm going to write it this way. I'm going to put 42 over 6, and they both have the 1/3 power, so I can put the 1/3 outside, and that's fine. And all of that is raised to the 2nd power squared. So my inside, work inside out. 42 divided by 6 is 7, 1/3 power squared. And then you multiply your exponents, so you get 7 to the 2/3 power. And that's it. It's a lot, but that's it. All right, properties of radicals. Radicals, you're allowed to multiply 2 radicals together if they have the same index and get a bigger radical. You can also break down a big radical into more than one radical by using multiplication like that. Same thing works with division. If you have a fraction inside, you can break that up into 2 different radicals. Okay, so let's try a couple here. First one says cube root of 135. Now, cube roots, first of all, you need to use cube numbers to break down cube roots. So what I'll do is keep in mind a list of that's 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, it's 125, 6 cubed, 7 cubed, and I could keep on going, but those are cube numbers. So I need to find one of these yellow numbers down here that go into 135. And luckily one does, and it is 27. 27 happens to go in there 5 times. So I'm going to break down that one like this. Cube root of 27 times the cube root of 5. I know the cube root of 27, since it's the 3rd number down here, the cube root is 3. I cannot break down 5 at all because none of the numbers in the bottom row down there go into 5. So that's it. That's all you can do. 3 on the cube root of 5. All right. The next one has 5th roots. And because it has 5th roots, I'm going to have to use some 5th root numbers. So 5th roots are like 1 to the 5th, 2 to the 5th, 3 to the 5th, and they get big in a hurry, so that's a 32, by the way. So I'm going to stop right there. I could keep going if I need to, But what I'm looking for, I cannot have a radical in my denominator. So what I'm looking for is something, a fifth root number or fifth degree number that 8 goes into. And 8 goes into 32. So that's what I'm going to use. 8 goes into 32 4 times. So I'm going to multiply the top and bottom of my fraction by 4, fifth root of 4. Because what that will give me, my numerator gives me fifth root of 28, that is what it is. But my denominator gives me fifth root of 32, which is that number, and 32 has a fifth root, which is 2. So I'm going to end up with the fifth root of 28 over 2. You cannot leave a radical in your denominator, so you've got to find something that the number in your denominator goes into so that you can get rid of your radical. All right, this slide, hopefully a little faster. First one. If you have the same index, same number inside your radical, you can just add your radicals together. So that's like 1 on the fourth root of 10 plus 7 on the fourth root of 10. That's 8 on the fourth root of 10. No big deal. Same thing here. Remember, a fraction exponent is really a radical. That's really the fifth root of 8 and the fifth root of 8. So if you add 2 on the fifth root of 8 plus 10 on the fifth root of 8, you get 12 on the fifth root of 8. And that's all you can do there. Now, part C, you got to do a little bit of work on. Part C has cube roots again. The numbers aren't the same inside, so you cannot subtract them unless you can somehow break them down to make them the same number inside. So cube numbers again, here we go. 1 cubed, 2 cubed, 3 cubed, that's all I need because I know 27 goes into 54. So I'm going to break down the 54 using, all right, since 27 is down there, it's cube root of 27 times cube root of 2 minus that cube root of 2. Now, cube root of 27 is one we know. It's its third number, so it's 3. So it's 3 on the cube root of 2 minus 1 on the cube root of 2, which is 2 on the cube root of 2. And don't forget to draw your little 3 for your index, or it will not be good. All right, hang in there with me on this slide. I got 4 problems, so just hang in there with me. First one is a cube root problem, and it says cube root of 64. The cool thing about this one is, don't forget the cube numbers. I've done this 3 times now. 1 cubed, 2 cubed, 3 cubed, 4 cubed is 64, which means the cube root of 64 is 4. I'm just taking the 4 right out of there. Now, the reason behind the slide mainly is to figure out what to do with the variables. What you do is you always take the best way to do it. This is cheap. Don't tell me I told you this. You take the index and divide it into your exponent. 3 goes into 6 2 times, so I'm going to have 4y squared. All you got to do. Okay, 27. We have an exponent outside. Sorry, part B. I said 27 because it says 27. So the 1/3 goes for everything. 27 to the 1/3 power. P cubed. I'm going to multiply my exponents. 3 times 1/3 is 1. 12 times 1/3 is 4. Now all it leaves is that 27 to the 1/3, which means cube root of 27. And look down here. 27 has a cube root. It's 3 p q to the 4th. And you got it. Part C. Variables here, and we can break that down into 2 pieces. You can break a fraction down like this: the 4th root of m to the 4th over the 4th root of m to the 8th, and treat it as 2 different things. And remember, we're dividing. Anytime we have variables, we're going to divide our index into our exponent. 4 goes into 4 1 time. That should be an n down here. 4 goes into 8 2 times. That's all there is to it. And the last one, let's look at D. D is straight up division, so I'm going to subtract exponents. But before I do that, first thing I'm going to do is do 14 divided by 2, which is 7. X, on the top is x to the 1st, on the bottom is x to the 3/4. You subtract those, and you remember it stays where your biggest exponent is. So it's going to be 1 minus 3/4 is 1/4. My y is okay, it's positive, there's nothing to combine it with. My z is negative, so it needs to come to the top. So it's going to be z to the 6th. That looks kind of weird right there. So my final answer is z, x to the 1/4 because I subtracted, y to the 1/3 because there's nothing to do with the y, z to the top because it's negative, so it gets flipped. And there it is. All right, another one, simplified one. This is going to be a little bit uglier. This is fifth root. There is no fifth root of 4. Nothing goes into 4 that has a fifth root, so you're stuck with the 4. So when I write this, the 4 is going to stay inside because there's no fifth root of 4, and you can't break it down. Now, the variables. Remember, divide your index into your exponent. So I'm going to go say, how many times does 5 go into 8? Well, it goes 1 time, so I'm going to take 1/8 out. What's the remainder when 5 goes into 8? The remainder is 3. The remainder always stays in, so I'm going to leave 3 A's in there. Same thing with the B. 5 goes into 14 2 times. I'm taking out the B squared. There are 4 left over. The remainder is 4, so 4 stays inside. And do the same thing with the c. 5 goes into 5 one time, no remainder, so nothing gets left over, and you're done. That's all you do on that one. Leave stuff in, that's okay. So let's go to part B right here. On part B, I'm going to break it up into two pieces. Cube root of x over cube root of y to the 8th. Now, you know what's illegal here. I cannot leave a radical in my denominator. So, and 3 doesn't go into 8 evenly, and I need to be some number that goes into it evenly. So what I'm going to do is I'm going to make that y to the 8th become y to the 9th by doing this, multiplying it by another y. And that's legal as long as you do the same thing to the top. So my numerator, if I multiply my cube root of x times cube root of y, I get cube root of xy. My denominator, now all of a sudden I have y to the 9th power. And see, 3 goes into 9. So what I can do now is I can just, my numerator, I'm done. That stays. My denominator, if you divide your index into your exponent, and you get y cubed. And that's it. That's a lot of stuff, I know. We're going to work on this in a couple of days, so, be patient. Last slide. Perform what it says to do. The first one, I love the first one because the square roots are the same already. It's 1/5 on w plus 3/5 on w. So you can just add your fractions outside. 4/5 on the square root of w. No big deal there. Part B, the same thing. They're like terms. X to the 1, xy to the 1/4, xy to the 1/4. So I'm just going to subtract my 3 minus 8, negative 5 xy to the 1/4. And then the last thing here, they're not the same. You kind of had to know that was coming. So what I'm going to do is I'm going to break down the big one. I'm breaking this one down. It's a cube root. Here are my numbers again. 1 cubed, 2 cubed, 3 cubed. That's what I need because that goes into 54. So I'm going to break this one down using a 27 and a 2 because 27 goes into 54 and 27 has a cube root. So my first one, I can't break down. Yes, I can. 3 goes into 5 one time, so I can take out one z. And what that's going to leave inside is the 2, and the remainder would be 2, and I did that, so it leaves a z squared in there. Watch what happens here. This is amazing. I'm going to take the cube root of 27, which is 3. So that comes out. There's already a z out there. It's going to be a cube root. Now, what does that leave? It leaves a 2 inside and a z squared inside, which just happens to be the same thing I had over here. They're the same. So I'm just going to subtract the numbers in the front. 12z minus 3z is 9z. I'm not sure why I changed colors. On the cube root of 2z squared. And that's it. That's a doozy. And like I said, we'll work on this quite a bit. Don't freak out if you don't get everything on the video. Remember, it's an intro. That's all it is. I promise to work on this really hard in class. And by the time we do several, I think you'll be good. See you tomorrow.